All right, so let's go to the electron transport chain. Okay, so you know we are in the mitochondria. I'm going to draw a little mitochondria here. Okay, and we're basically working in the intermembrane space and the matrix. So we're kind of working across the inner membrane. So we're working like here. Okay, if that makes sense. All right, so let's draw just a big, like zoom in on that. To get in the way. Okay, so if we have our cytoplasm is here. Okay. Here is the outer membrane. Okay. And then here is the inner membrane. Okay. And this area here is the intermembrane space. There. Okay. So basically we have some high energy electrons that are being carried, that are being saved, that we can cache in here at the electron transport chain. So how many do we have? So we have let's just sort of make a little bank here. We have 8 NADH and 2 FADH from the citric acid cycle. So that's 10. Or that's basically the citric acid cycle and the transition reaction with it. So that's 10. And then we have 2 left over from glycolysis. So we have 12 high energy electrons that we can use. Okay. All right. So on this membrane, on the inner membrane, there are proteins. They look, so I'm going to do them like this, but they're proteins that get a little bit smaller as they go down. So they're in kind of like a line, right? And inside the matrix, we have, or there are, hydrogens. Hydrogen ions. Just in the matrix, okay? And what we're going to do is use these high energy electrons to fuel these proteins, which are pumps, and we're going to pump these hydrogens into the intermembrane space. And we're going to create a gradient. We're going to create a bunch of hydrogens out here that are going to want to go back into the matrix. And we're going to do that with these electrons. So we're going to take these electrons and we're going to bring them up here. Here's this electron. Here's this electron. And when we do that, it's going to pump hydrogens into the space, okay? Into the intermembrane space. All right, these electrons then are it's going to use some of their energy, and then they're going to sort of hop down to this protein. And when it does that, then this protein is going to barf out hydrogens. Then the rest of the energy is going to go down to this one, and boom, more hydrogens coming out here. Okay. Once this, why are we putting hydrogens into the intermembrane space? Well, the reason is because there's another protein here. And this protein is called ATP synthase. And it's kind of like this little machine thing. And it has this like little crank in it, sort of thing. And basically what's going to happen is this is how the hydrogen, this is going to be the only way these hydrogens can get back into the intermembrane space. So they're going to come in here, and when they come through and out, it's going to turn this little crank thing. And when that occurs, we're going to get ADP plus PI, inorganic phosphate, and we're going to get ATP. So every time a hydrogen comes through here that we pumped into this intermembrane space, we're going to get an ATP. Okay? All right, so we have 12 electrons. So we can do this 2 at a time, 6 times. Okay? But what happens to these 2 at the end of the chain? Because these can't hop on if these don't hop off. We're going to get a log jam here. Okay? That's where oxygen comes in. Remember the video where we talked about the equation? So C6H12O6 plus oxygen gives CO2 plus water plus ATP. And we said that the glucose was oxidized, it's broken apart, and the oxygen is reduced. So we're taking electrons from glucose and we're giving it to oxygen in the end. So we've got oxygen down here. We've got oxygen here. And these electrons hop on oxygen. And when they do that, we get water. So in this situation, we call oxygen is the final electron acceptor. So the electrons hop off of here, they attach to oxygen, make water, and these electrons can jump on. And it does that and does that, and we make ATP that way. So per 1 molecule of glucose, we end up with about 32 ATP. This process here, where the hydrogen goes in here and creates ATP, that process is called the chemoosmotic process. Use a different color. The chemoosmotic process. And basically, the chemoosmotic process basically couples the movement of substances, in this case the hydrogen, so the movement of substances across, to erase this, so across membranes, for chemical reactions. So that's the chemoosmotic process, and that's what's happening here. The hydrogens are moving across this membrane and creating ATP from ADP. All right, so that is cellular respiration. We looked at glycolysis, we looked at the citric acid cycle, brought the electrons over to the electron transport chain, and we made 32 ATP. Okay. All right. So now let's look at lipid metabolism.